So here we have this drawing. This is your first drawing, 3 of 24. You're going to do a sectional view of it. You start with the correct units of measurement. This is a metric drawing, so you need to start in the correct units of measurement here. We did, but just in case, if you ever look at a drawing and you're trying to assess what units of measurement am I in, you can actually look, of all things, the quickest way to find out if you're in the correct units of measurement is to go under annotation and see what kind of dimension style you're in. The default dimension style, if you see ISO-25, you're good to go. If you do not see ISO-25, you're in the wrong units of measurement. If you see standard, you're in inches, which is a big problem. Got it? That's the quickest way to assess, and that's how I did it on some of your drawings when you're like, why are my hidden lines not showing up correctly, blah, blah, blah. That's the reason. So your first order of business, of course, is to go ahead and just draw a line. I usually say draw a nice center line for yourself. Make sure it's a reasonable center line, not too large, not too long. This unit's like about 100 total, roughly. Just over 100 millimeters long. So when you draw a circle, if I start at the end, that diameter is going to be on that end is 44. So that's just, am I in radius or diameter, guys? When you look up here, where you see the little dashed line represents what you're in, and the words are right there on the screen. Specify radius of circle. So if you want to do diameter, you have to do a right mouse button and select diameter. And then it says specify diameter of circle. Make sure you remember that. So in our case, the outer diameter is 44. See how much smaller that is than the line I drew? Then you can actually draw a rectangle if you were so inclined. Some people want to do that. They'll just go ahead and start there and reference out here somewhere, because that's what they want to draw. The problem is when you draw a rectangle like that and you start bringing it up, you're not going to be able to draw that correctly. So I usually recommend just draw a line. Make sure to track up to where you want it to be. The length is 88. Then you drop down. You can always track. Don't forget tracking. Tracking's a beautiful tool. In this case, I can't track across, but I can at least draw a line there and start my next line here to there. Doesn't matter that this line extends past the object, because when you use the fillet command, you can always trim. Remember that. When you go to fillet, remember right mouse button, pick radius. The radius you want to use is what? 10. So then you pick your two objects, and then it'll trim off the rest. You don't have to sit there making it perfect. It'll do the work for you. To create a slot is just another circle. You want to make sure it's drawn in the right spot, though. So I do always suggest drawing some reference geometry for yourself. Extending your lines out, because ultimately these lines that I'm drawing will become what? Your what to the entire object? Yep, your center lines. It's no big deal. Okay? Now I'm going to use the offset command. I am intentionally typing it so you can see that the options are there. Offset, and I'm going to type in 54, so that's where my center line will end up being for my circle. Then I drop my circle, it's radius, which is fine, that's 10. And then I can just go ahead and draw my lines connecting this and trimming. So all this is straightforward. That's why I went really fast, because these are the things you know how to do already. So I'm trimming, nothing fancy there. And I'm trimming this, nothing fancy there. The fancy will come when I have to convert lines, and I think I showed you guys how to do broken lines. This one's a diameter, so I'm going to enter diameter 30. Okay. Offset again, I got to put the slot in the back, so I'm going to offset up, offset down. And I'm going to trim. I'll do the outer part independently of the inner part, because I wanted you to see what happens. When I do trim, you'll notice it only trims what's inside, what touches this circle. So you have to remember to remove the rest, because trim is based on where the perimeter is. So you have to be mindful of how you trim. Like here, because I picked everything, I have to trim both sides of this line back. So that's the top. Of course, what's wrong? Well, I don't know. Maybe nothing. Depends on how you choose to section this view. Remember, this is supposed to be represented in what angle projection? It's metric, so what angle projection? First. But I also told you that it needs to be a full sectional view, which means we're going to literally slice through the middle of this object. Okay? When you slice through the middle, and I'll carry some lines down just to show you this. You're going to carry a line down here, or up, it doesn't matter. I just want to show you how it's going to look. When you carry that line all the way down, I did a line, and then I'm doing one more, 44. Where I drew this first line really doesn't matter. It's the second line that matters. That's the one that's the correct length of 44. Then of all things, I'm going to offset 44. So I can offset this way. You might want to ask me, why don't I carry this line down? Okay, and I can, but I want you to see there's a slight difference. That slight difference is a product of the fact that this has a cut through it. I need you to appreciate that reality. Okay? So you don't want this other line, that little line that was offset 44. You do want to project your lines down. That's the important part that I'm trying to show you. You have to project your lines down from the view so that you get the correct position for everything in this view. You cannot say, well, that's 44, so I'm just going to go ahead and offset it, and that's it, because that dimension is wrong. And you'll notice I'm going all the way across. All of these lines are reference lines. This is the only one that'll be stationary. The reason I have that line in there is so that I can go across to basically save some time in how I draw. That's why I did that, just so you could see that. Then if I go to trim, I can trim off those lines the same way as if I had a hand drawing. And you'll notice the only line that didn't trim back was this line, because that line ended at this line. And that was the first line I drew just to give me space, and then I drew this line, which really is the bottom of this object that defines this bottom position. So now I can trim off these lines here. We're not done. I'm just cleaning up the drawing a bit. Then you have the thickness of this, and that's another offset. You'll notice how I use offset a lot. Remember, that is the power of AutoCAD is not in drawing, it's in using the modified set of tools right here. This is where the power is, right here, in modify. So use it. Distance of 15, that defines this height. Now you'll notice we've got the thickness of the part, not the, we've got a gap here, because this is going to be a trimmed object. I'm slicing through the middle of it. When I'm slicing through the middle of it, there's pieces that are going to go away. Those pieces are related. I see this object here, right? Then you have this thickness of this object somewhere in that body. And then you have the thickness of this object until it hits this point. And then you have its total length out here somewhere. So what I'm doing is creating a slice of this part. I'm doing a very bad job of sketching that because I'm using my mouse, but all of that comes from here. When you look at sectional views, the PowerPoint on sectional views that I have as a reference for you in the reference book used for this class, you're going to find out that you're slicing objects in half. So hopefully you reviewed this PowerPoint, but that's literally what we're doing. We're slicing the object in half. As we slice it in half, we see different elements of that view. The stuff on the inside that we can't otherwise see. That's what you're going through. This one's an offset sectional view, and that's the one I'm going to show you next. Because what I did right now was a full sectional view, was slicing the part literally in half. This guy right here, we just sliced it in half. That's what we're doing here, we're just literally slicing half of it out like an apple. The next one I'm going to show you is this one, which is an offset sectional view, so you're slicing through multiple elements of the object. So, and that's some other examples that are in there, inside Blackboard for you. So now I have my basic shape. I've got this object and this object. This is my front view or my top view. I don't know. What will we call this? Remember the orientation for a metric drawing. In a metric drawing, you'll have front view, you'll have top, and you'll have the right side view. Because that's what first angle projection is, remember? When we had that conversation a while ago. First angle projection is what you'd want to draw this at in order to comply with ANSI standards. Not ANSI, ISO standards, because this is a metric drawing. If it was an inch drawing, then it would be ANSI standards, and that's third angle projection. In this case, it's a first angle projection drawing. So when you look at this object and respecting the cube, what's the front, guys? And the cube is always respected, regardless of angle of projection. The front is where the cut is, correct. The front of the object, the front of view is also your sectional view. 100%. You're correct to say that. So this is the front. Your sectional view can also be your front view. Your sectional view can also be your right view. Your sectional view can be the auxiliary view. Your sectional view can be the top view. Get it? Your sectional view can replace another view. So don't feel the need that you have to draw a front view and a sectional view, or a front view or a right side view and a sectional view. If they are identical and that's representative in that position, yes, you can do it. That's why I picked this object, in order to teach that particular element. A particular view can also double as your sectional view. Okay? Please make sure to include that in your notes. So in our case, this will be my front view. So what is this? Understanding the rules of first angle projection. If this is my front view, what did I draw up here? What's this? Nope, it's not my top view. Look at the rules here. Correct. If my top view is down here, my bottom view is up here. Okay? The reason that's important to understand is that defines what happens to the inner part of this curve. Okay? When you look at this object, this outer curve, half of it is either going to be a hidden line or it's going to be a solid line. If, and I'll copy, that's the beauty of CAD, I can just copy it, hit enter and drop it. Come on, you, enter. Alright, let's try that one more time. Copy, pick my objects, hit enter. Where am I going to? Where am I going? There we go. So that is what, that's what. If I have this for first angle projection, what have I got? Front view and top view. What's wrong with my top view? Yep, I'd have to break my lines. I need to break. Now, where do I find break? I forgot. We covered this a couple weeks ago. We had to break for another object when we made something else, calipers. Would I find modification items under draw or modified? Modified, okay? And then there's different types of breaks. I've got a break that involves a gap, and then I have a break that involves no gap. I want to pick that one. That's the one we use for the other object. So I have this object at this point. Okay, hit enter. I have this object at this point. Now it did break it. Because I hit enter, it broke it using a gap. One second. So I undo. Alright, I gotta open this up. Undo. There we go. So right now it should have one gap in it. I have to actually pick the correct one, break, pick the object, pick the location that I want it to break. That way my inner object now can be changed. Remember, if my line type isn't in there, so what? I can just go ahead and pull it in. Now remember, when you're going to load line types, it's in AutoCAD ISO, so it's in the correct line type, which is important. You've got those options. So you can do AutoCAD ISO dash, which is the same as hidden. Okay, if I do that, that's fine. Then I pick this object and I change it to ISO dashed, and I get a nice dashed line. Okay, if you pick hidden, which you might do, and I understand why. You click in here and you go H for hidden, and you pick hidden, and you click the object and you pick hidden. I think you're gonna, oh, it did it, darn it. Because I'm in the correct units. Those of you who are in the wrong units, remember what happened? Nothing. It stayed a solid line, right? I'm in the right unit, so it knows. So it adjusts. I had to tell you guys to do a, what was it, a multiplier of 25.4 or something so that you can see it clearly. But then I said it's still wrong because you can't work with an inch drawing and tell me, and lie to me and tell me it's a metric part. It's not going to work. Because when it moves over to the software and for the CNC or the machining side of the house, what's going to happen? You're going to get the wrong size part. So you can't do that. The other one I want is a hidden line. I'm sorry, center line. So let's pick center. Now I should see something different. If I pick my 4 lines, not 1, 2, 3 lines, and turn them into center lines, what do I get? There we go. Don't have a fit over the fact that the center lines don't match up with each other. I have actually had students quite upset that the lines, I can get these lined up, and then I've had people complain that they couldn't get the center line to line up correctly. That's okay. Don't. It's not going to happen. Okay, when you're doing hand drawings, it's easy to make them be perfect. When you're doing CAD drawings, you don't have that level of control. You lose it. So that is what the projections would look like if it was metric front view with top view. If it was metric front view, bottom view would look like this. Okay? I'm doing this for illustrative purposes up here. You do not need to do, you're not going to show all 3 views. It's a waste of time. But I need you to be aware of them. Don't forget your other rules with line weight. What did I say? What's object lines? 0.6. Okay. What you can do, remember, you can pick one object and change it to be that line weight. Now I forgot. Okay, I changed it, but gosh darn it, it doesn't show up on the screen. What did I forget to do? When you go to line weight settings, what do you have to do? Click on display line weight. Remember that, please. Okay, remember that, because I promised not to. Then you go to match properties, and then you can select that item, and then everything will be like it that you select after that. Notice that? Quick method. Wish you had that the other day when you were trying to do this. Any of you? To remember that? It's a quick method of adjusting your lines. You have to be careful what you select, because whatever is in your crossing window, if you go right to left, it's only what's inside the window, but if you go left to right, it's whatever is touching the window. Please remember that. Okay? Now you notice I didn't touch the hidden line, because that is supposed to be thinner, right? I didn't touch the center lines, because those are supposed to be thinner. So your object, if you're going to do this presentation, needs to look like that. That's the correction that has to get made. Now you're going to ask me why. Why is this solid lines? Your last step is to put in the hatch. Now this hatch came out thick because I was in the middle of using that other line weight, and I actually had that active.
Can you do that whole step out again?
I recorded this whole thing, so you'll pull the recording on it. So there, I fixed it. But hatch is right here, so you pick whichever one you want. I picked ANSI 31. You can pick whatever you want. I would recommend picking either ANSI 31 or 32. Doesn't matter which. And the 31s and 32s, they all actually define a particular material type. That's covered in a different class. So for here, it's just be aware of it. In a different class, I cover the details of that. So this drawing, if I was going to draw a front sectional view and a top view, would look like this. If I was going to draw a front sectional view and a bottom view, would look like this. Anyone want to wonder why I didn't put a hatch on this side? There's no cut in there. You'll see? It goes through a gap. Anywhere there's a gap, you don't put a hatch. Anywhere there's a gap, you don't put a hatch. Okay, the only place you hatch is where you're actually cutting through something. When you're cutting through material, that's where you put the hatch. Now, your line type up here has to change, because the line type for a hatch in the metric system is a well, it's a couple of different ways, to be honest, from what I've seen. ISO dash dot is fine. There's a couple of them. Long dash dot is fine. So I've seen it a few different ways. This did not change though, so let me double check. Oh, because I haven't, oh, there it is. The dash dot's right there. So there's that. It has to be a very thick line type, so the line type I always recommend when we do stuff like this is a 0.6 millimeter thick line. The only thing you cannot do in AutoCAD is put in the arrows. Because when you look at a metric drawing, I have to move this over and just try to emulate it here. The metric drawing, and I put this on the board the other day before I got it distracted and had to leave. I'm going to try to hand sketch this over here with the guarantee that it's going to look bad. When you have the hatch, you can do one line good, but not the rest. When you have this, in a sectional, the way that it's done, it's a thick arrow pointing in the direction that's going to be visible. Meaning, over here, if I just try to facsimile it real quick, just to make a ugly looking shape, it's like that. That's a very ugly shape. That's not the one you should make. But you would do something that looks like that, but in a nicer way. And that is telling you, hey, this is your cut line. I'm pointing at it. Get it? I'm pointing at the cut line. And this is the cut object. That's how you're alerting people that it's sectioned. Okay? Now, this particular shape over here is too large. What would be a good shape? You could always go back and forth on that. Let me scale this down to something reasonable. Let's say half of that shape. And being picky as I am, I'm going to mirror this side. The angle doesn't matter so much, but if we wanted to get really, really picky, I'd say probably something in the 30 to 45 range. And the inside, you're going to fill it in with a solid hatch, not a gradated hatch. Under hatch, you do have the option for if I pick hatch. Because the last one it did was this hatch, it automatically wants to put that kind of hatch in there. You're going to fill it in, but you want to fill it in with the hatch pattern of solid. That way you'll get a solid arrow. This side, the dimensions of this, I did, as you saw it, I freeformed it, right? And this needs to be a continuous line. It is not a fancily drawn line. I will warn you. If I had to identify its dimensions, which I will for you right now, it's approximately 9 millimeters wide on this drawing by 7.29. See that? Not precise. Those are the rough dimensions of this thing. So you have a rough idea of what you'd want it to be for this drawing. So it's complementary to the shape. as far as its size. It's complementary. There are more precise measurements. I don't get too precise on them because I've seen so many variations in the field. This particular thing is the first time you'll ever hear me say I'm not too picky. And it's going to be exactly the same when you do an inch drawing sectional. And in there, instead of the arrows going toward the line, the way you see them, of all things, are going away from the line. And instead of this line, the section line itself extending past the object, in a inch sectional view, they actually end at that point. And I'll show you one of those later. But for now, I'm showing you a metric version. Now, the next thing you want to assign, of course, are all the dimensions. And you want to be extremely careful in how those dimensions are done. Do you see any issues with anything yet? Any thoughts? Just asking. What am I missing? Am I missing anything? Obviously, I'm missing the dimensions. What else? What did I forget to do with these two lines?
Bring them down.
Not bring them down. What did I forget to turn them into? Center lines? Because those are still center lines, even though they're not. You know, the horizontal line became a sectional line, right? But the center lines are still there. You don't bring those lines down. You don't bring them down here. In a sectional view, it's the only time you don't include those features. In sectional views, you don't include them. The biggest things you're going to identify here on the metric side is you have to make sure your dimension standards are correct. Okay, so you want to make sure your text is the correct height. What is your text on a metric drawing? 1/8 of an inch times 25.4, right? So what's that number, guys? 0.125 times 25.4. Yeah, it's not 2.5, it's 3.175. Those are the changes I would have you make. They stay aligned with dimension, that doesn't change. But your text height has to be bigger. Your arrows will stay as arrows, that's fine. There's no issue there, but this also changes because that's 3.175 as well, because they're an 1/8 inch arrows. The rest I don't worry about. Your lines are also, your baseline spacing changes because your first dimension is 1/2 inch off the part if it was inches. That means when it's metric, it's 12. Oh, that's not baseline spacing. What is this, guys? What's the baseline spacing, guys? That's not the gap. What is it? It's the. It's what? How far away is the object from? How far away is the dimension from what? From the object. So that's also 3.175. So what you have to remember, it's recording. What you have to remember is to the baseline spacing. You have to convert everything to the metric system when you do this. All right, symbols and arrows, text is 3.175 fit. You still want to say place text manually, draw a dimension line between extension line is fine. Your either text or arrows, this is fine. Primary units, number of decimal places. When it's a metric drawing, how are they going to appear? As commas. Remember that. If you have that. Okay? If you have that. Okay, we have a visitor from who just walked in, and they'll be in the recording, but it's okay. But in the metric system, you don't use periods. You use what? When you denote decimal sign. Yeah. Commas. Okay? And that's right straight out from someone from Europe. So there, you got it. I'm not going to put them on the spot on the video, but that's what's going on. I'm not telling you anything that's not true. Okay? So please appreciate that. And it even says decimal separator, comma. That's the default setting. Then when you put in your dimensions, remember the rules are here also the same. So when I want to position my first dimension, what's the distance? 12 something, right? I would go offset 12.7, right? Did I go into offset? I don't remember if I got, whoops, my mouse is in the wrong spot, that's why. If I go to offset and I type in 12.7, this is how I can position my first dimension. And every other dimension after that is 3/8 of an inch away. That's 3/8 of an inch in relationship to okay, 3/8 of an inch away is what, guys? 0.375 times 25.4, 9.525. So when you do offset again, cancel to be able to offset, 9.525, that's where your next set of dimensions will go. So when we look at our drawing here, kind of see what dimensions are going where. So your first dimension, now, is my line way too thick? Does it matter for what I'm drawing? Those are reference. I'm going to erase them anyways. So I'm going to drop my dimension. Here's my first one. Ooh. What else is wrong, guys? These lines are a little too long. My center lines are a little too long. So I got to move them in a little bit. See how I can pull my grips? You want to dimension to your center lines, not into the object. Just please remember that whenever you have center lines. I'm going to do a match properties to fix the line weight problem, but it didn't fix the line type problem because now it's a center line. So I have to change this to bilayer. Okay, and I'm changing the line type to bilayer. So now I can drop in my next dimension, which is from here to here. Still coming out the wrong way for some reason. I'll have to check on that. But if I position this properly, again, match properties, pick this dimension. Nope, wrong direction. I had that one activated by accident. So when you do match properties, make sure you hit escape a few times before you hit match properties. Just a word of advice. Pick the object I want to match to, then pick the object I want to change. And that object behind it is the reference line. And there's your first two dimensions. Got it? The rest you can put it on your own. You never dimension in this view. You never dimension things you cannot see in the view you can't see the object in. So do not put your 54 and 88 dimension down here. It's in the wrong place. You never put your dimensions in that view. You have to put them in the view where you see what you're dimensioning. Just like the height. I would never dimension the height in the top view where I can't see it. I would dimension it out here. Now what did I forget to do? For some reason I'm hung up on, there we go. There we go. The line, by layer line information was wrong. There we go. So now what? Offset what? What's that dimension? 12.7. If you write these in your notes, you don't have to keep checking your calculator. Got it? So write it in your notes. 3/8 of an inch equals 0.9525. Half inch equals 12.7. That way you don't have to keep saying it over and over again. Offset 12.7. That way you can position things quickly. Because trust me, employers want to hire people that are fast. They're efficient, not somebody who keeps looking at them saying, what do I do now? What do I do now? I don't know how to do that. They're not going to hire you, or you won't be hired. You won't be retained very long. Let's put it that way. Okay. So make sure to make cheat sheets for yourself. That's what I'm telling you right now. So that way you have this information handy. So when I ask, what's that distance? Hey, it's in your notes. See that? Your dimensions must always be oriented in the same direction on a metric drawing. This orientation. You can't rearrange your dimensions. Okay? Can't rotate the 15 to the other side for some reason. That's not the standard. So these standards are built into the computer system. They're the same standards we follow in hand drawings. So those of you in my hand drawing class, sound like a familiar conversation? It is. Where do they come from? Not my brain. They come from the industry standards. I'm not making the stuff up. So there's those dimensions. I'm ignoring this guy down here. I'm just going to get rid of it because that's a view I don't need. You've got your radius. You've got every single dimension that you have to drop in here. So you're not quite done. There's your radius. There's this outer dimension. Now, if you want to change your radius to something else, what do you have to pick? The something else. Diameter. You have to actually pick the other item. If you don't want it to be a radius, you want it to be a diameter, you have to pick it. Make sense? Now, you'll notice like if arrows are out here, that's the standard position for them. That's okay. That's a metric drawing. That's how it dimensions it. All right? And if you're saying, well, it doesn't look like this, well, this is not to metric standards. If you look at the dimensions, how do they look? They're to ANSI standards. The dimensions are in between the boxes, in between the lines, I mean. See that? So, and then you have a reference dimension. You see this 22? It's in parentheses. That means it's there for reference. It's just basically telling you it's centered. Okay? So if you have all the dimensions you need, now you see how this one says R10 and TYP? The reason that's there is typical. It means that this radius is also the same. So if I have another radius in here that's not dimensioned, it should be also 10. Now here's the funny part. If I wanted to get slightly obnoxious, I don't even need to put in this radius. Why? Because it's also 10. Notice that? But rule of thumb tells me to put that radius in only because it's not the same kind of radius as this. Meaning this is the inner part of a slot, and this is a corner fillet. It's the only reason I would put that dimension in twice. Even though in your mind you might say, I don't need to put that dimension in. Only because it's dimensioning a different type of feature. That's the only reason we put it in. But this guy, hey, the tendon, how do I put in typical? You can right mouse button, and if you want to edit this object, you go to its properties. And in here is everything about that object. Everything. Okay, all the information you want to look at. The color, the layer, the dimension style, the arrow sizes, the text itself, the text measurement, and the text override. This is an example where you would override the text. You'd put 10, you still have to put that in there. Because once you do the override, if you only put in TYP, let me put that in parentheses the way that, in caps, so don't forget, in caps, if you only put in TYP in there, that's all it's going to show you. So you have to put in the 10 in front of it in a little space, one space, okay? That's text override, okay? And that was found under right mouse button, properties, when you click on that item specifically. That's when you get to do that. And that's how you would fully dimension this item. Now, I am breaking the rule when I told you for creating the border. I'm doing it real quick on the side here, but I'm basing it on the interior dimensions. And what are the interior dimensions of a border, the drawing area? What are those? 7.5 on the height, which is the equivalent of 190.7 in millimeters, 10.5 on the length, which is 266.7 in millimeters. So I'm going to make a rectangle, dimension it to what? 266.7 on the length and 190.7 on the height. Did I type that in right? 190.7 not 19, 190.7. So I did it the wrong size, didn't I? So rectangle, right mouse button, dimensions, 266.7, 190.7. Okay, so if I look at this and I move my frame in, will it fit in there at 101? Yep, no problem. This drawing is 101 scale. Yay! It's simple, it fits in the border, there's no issues. And what I drew was not the entire border, all I did was draw the rectangle that represents the inner drawing space of my border for this class. Got it? That's all I did. So that way I can instantly tell, will it fit at 101 scale? The answer is yes, we're good to go. Cool? So the last step would be to finish off the border, put in the bottom part, you know, and that you have your handout on creating the border, which is inside Blackboard, under the section, under the in-class homework, under the section called Border Dimensions. This handout. Let me see if I have the option to rotate clockwise. This handout, guys. Okay? All I did was draw the equivalent of 10.5 by 7.5 in metric. That's all I did over here, just to make sure it'll fit in their 1:1 scale. So this drawing is 1:1. Not every drawing is, but this drawing is. And that, once you finish this off, that's what you would then save to PDF. Be careful on that. There's another video that I posted already on how to do that correctly. And then that's what you would actually save to PDF. I want you to print it for yourself so you see how it looks. And you're actually handing me the printed document. Okay? Questions before I cut off the video? All right. That's it. That concludes this video.